Section 1.8 is on exponents and order of operations. We start by evaluating exponential expressions. To simplify 2 to the 4th, we recognize that it is the same as 2 times 2 times 2 times 2, or 2 times 2 is 4, times 2 is 8, times 2 is 16. Similarly, 4 to the 3rd is 4 times 4 times 4. 4 times 4 is 16, 16 times 4, that would give us 64. In the first example, 2 to the 4th, 2 is called the base, and 4 is called the exponent. Okay. So I want to find the value of each of the following exponential expressions. 3 to the 4th is the same as 3 times 3 times 3 times 3, 81. Negative 2 to the 5th is the same as negative 2 times negative 2 times negative 2 times negative 2. These negatives aren't showing up very well. Let me darken them. And one more, negative 2. This expression has 1, 2, 3, 4, 5 negatives. 5 negatives will be negative, and 2 times 2 times 2 times 2 times 2 is 32. Now the parentheses really come important when my power is even. Right here I have 5 negatives, and 5 negatives make a negative. In letters C and D, the problems are basically the same thing, except that one has parentheses and one does not. This right here is the quantity negative 5 squared. Let me use a different color. It's the quantity negative 5 squared. The quantity negative 5 squared is negative 5 times negative 5. 2 negatives make a positive, so this answer is 25. Whereas in the next one, this is negative 5 squared. Negative of 5 times 5. 1 negative for a negative 25. This is something that I need to be particularly aware of when I use my calculator. Let's take a look at how that works on the actual calculator. If I want something to be negative 5 squared in parentheses, I must type the parentheses. I must type negative 5 parentheses to the second power. It does give me a positive 25, 2 negatives. If I simply type negative 5 to the second power, it understands that I don't really want the parentheses to be there, and that, like example D, it should be negative 25. So keep that in mind when you're using your calculator. The parentheses are not implied. You must actually type them when you mean for them to be there. Let's look at objective 2. Simplify an algebraic expression with exponents. These two terms are like terms because both of them have the variable x cubed. So 26x cubed minus 27x cubed is negative 1x cubed, or simply put, negative x cubed. I don't need to write the 1, it's implied in negative x cubed. And in 5x squared plus 5x cubed, that cannot be simplified because they have different exponents. So it's done as it is, can't be further simplified. Those two terms were not like terms. Alright, so our tip right here, variable terms are like terms if and only if the variable and the exponent are the same. Variable and the exponent are the same. Alright. Objective 3, use the order of operations agreement. So the order of operations starts with parentheses. And parentheses can mean a variety of different things. Parentheses might be the traditional parentheses, or brackets, or even a fraction bar or a square root symbol, all are going to fall into that parentheses category. The next, number 2, is exponents, or powers, followed by multiplication and division. The important thing to remember here about multiplication and division is that it's not always multiplication first, then division. It's whichever one comes first in the problem. Division. From left to right. So sometimes it'll be division first, sometimes it'll be multiplication first. Same thing about item 4, addition and subtraction. My A looks like a D, but that's alright. Addition and subtraction. It's not necessarily one first and the other. They're going to follow in left to right. Subtraction. Left to right. Let's look at a couple examples. So in the next problem, 7 plus 6 times 3. 6 times 3 is multiplication. I'll do that first. So it's 7 plus 18. Finish up with the addition. 7 plus 18 is 25. Let's look at the next example. There are a pair of parentheses, so we'll do those first. 4 times 5 is 20 squared minus 4 times 5 squared. So I took care of all of my parentheses. Now we're going to go for the exponents. There are 2 of them. The first one first, 20 squared is 400. 20 times 20 is 400. Minus 4 times 5 squared is 25. Notice that I cannot multiply the 4 and the 5 right here because this exponent is on just the 5. So I'm going to take care of that first, then finish the multiplication. So this is now 400 minus 4 times 5 is 100. And 400 minus 100 is 300. Alright, let's go to the next example. No parentheses here, so we're going to deal with the exponents first. 8 squared is 64, minus 16 divided by 2 to the 4th. So again, I'm doing these 2 pieces that have exponents. I'm sorry, there's 2 squared. 2 squared is 4, times 4, minus 3. Now for multiplication and division, I come across a division in the problem first. I'm going to make sure I do that next. So I've got 64 minus 4, 16 divided by 4 is 4, times 4 minus 3. Finish with the multiplication. So 64 minus 16 minus 3. 64 minus 16 is, I don't know, 64 minus 16 is 54 minus 6 is 58. So I have 58 minus 3 is 55. Alright, and the next one, this one has a lot of parentheses, so we're going to start with the innermost parentheses. This one's 2 times 5 plus 2 times 9 minus 4 is 5. Inside this next set of parentheses, I've got a multiplication and an addition. So we'll do 2 times 5 plus 10. Do that multiplication first, then the addition. So it's 2 times 15. And finally, finish with that last multiplication and get our 30. Making sure we work through the order of operations from the innermost parentheses to the outer. So the inside parentheses, then the multiplication, then the addition, then we finish the outside parentheses before we can finally do that multiplication. Alright, and the last 2 examples here. Let's start on the inside parentheses, which require an exponent first. So 2 to the 3rd is 8 minus 1. So we're going to do that part first. I'm going to rewrite the rest of the problem. And then we're going to work on the innermost parentheses. So we have 7 plus 3 times 7. Alright, and then we have an addition and a multiplication. Do the multiplication first. So it's 7 plus 21 divided by 4. 7 plus 21 is 28. And we're finally ready for that division. 28 divided by 4 is 7. And then our last example for this one, we've got no true parentheses, but we do have a couple multiplications to do here. Parentheses are where you have something to do inside of the parentheses. I don't have anything like that up here. But I have negative 11 times 4, negative 4. 2 negatives make that a positive 44. A 2 times a negative 7 will make that a minus 14. So I've got 44 minus 14 on the top. 7 minus negative, we'll turn that into 7 plus 3. So on the top, 44 minus 14 is 30. On the bottom, 7 plus 3 is 10. And then finally we can finish our division and get 3. Alright, in the next example, we're looking at an evaluation where I need to plug the x value in. So I'm going to do order of operations here once I've done that. X squared is going to become 3 squared plus 5 times 3. Using my order of operations, 3 squared is 9, plus 5 times 3 is 15, and finally 9 plus 15 is 24. Let's go to the next page. Alright, we've got another thing here to simplify with order of operations, and this one also has variables. We're going to work from the inside out on this one. So I'm going to start with 14x squared plus 5 minus. Now, I can't combine those parentheses because of the variable, but I can use the distributive property to simplify. So I'm going to have 7x squared minus 14 plus 4. Alright, now we're going to simplify inside the parentheses. So I've still got the 14x squared plus 5 minus the parentheses. No like terms for 7x squared, but minus 14 and 4 will combine to a minus 10. Now I've got another distribute to do here, making sure this negative gets distributed to both parts of the inside. So I've got 14x squared plus 5 minus 7x plus 10, two negatives. And again, we're going to combine our like terms right here. Oops, that was a squared, I forgot to write that. So we've got 14x squared minus 7x squared is 7x squared. And 5 plus 10 is 15. So we're able to combine our properties here using order of operations, the distributive property, and combining our like terms. Alright, objective 4, this one right here, I was looking for that line down here. Let me know that's the last example for this section. So in our last example, we've got Palo Alto, California. A government agency ordered computer-related companies to contribute to a pool of money to clean up underground water supplies. We're using this mathematical model. The mathematical model describes the cost, C, in tens of thousands of dollars for removing X% of contaminants. Find the cost for removing 80% of the contaminants. Okay, since the units on X are supposed to be percent, I'm going to leave the percent symbol here and use the number 80. I'm not going to change it to 0.8 because it needs to be in percent. That's what I'm told right here. So I'm going to have 200 times 80, the units are percent, over 100 times 80. And we're going to use order of operations again to simplify. 200 times 80 is 16,000 over 100 minus 80 is 20, and 16,000 divided by 20 is 800. Alright, and we need our units right here. So let's go back and look. Cost is supposed to be in tens of thousands of dollars. So that's $810,000, tens of thousands of dollars. Which sounds a little bit weird. Maybe we can put some more zeros on there to make this make sense. The units tens of thousands of dollars are $10,000. So my final answer, if I wanted to write it all the way out, instead of $810,000, I can say it would be 2 zeros from the 8, and another 4 from $10,000 would be $8 million. Okay, so the units are important here. It's not like it's $800. It's 800 in units of tens of thousands of dollars. So if 810,000s, which written out would be 800,000, or since I have 6 zeros altogether, it's $8 million.